we have this crazy looking image here, guys. Here's what this image means. I called this a swirl earlier. That's not really considered a swirl. I'll still use that term. This is called a point of inflection. Please write that down. And if you notice, the point of inflection, if you notice right here, that kind of looks like the beginning of the top of a circle. And then once it passes the origin, it like flips to like the bottom of the circle. So it's actually a change in concavity. But you don't have to know concavity. Just remember it's called a point of inflection. Also, this up here, this vertex, we're going to call that an absolute maximum. And the reason why it's an absolute maximum is because the graph goes down forever. Notice you have 2 down arrows. That is the absolute highest value the graph is ever going to be. Over here, we could possibly consider this a relative maximum. I mean, it is kind of a whole higher point in relation to the other graph, but it is not the absolute highest. It's just relative to this vicinity right here. So please remember all these words that I talked about, they are called critical points. They are critical attributes, critical points of a graph. And what we are going to do today is we are going to talk about the middle of the graph. A couple of days ago, we talked about this. Do y'all remember what that stands for?
End behavior.
Yeah, end behavior. End behavior. End behavior is just the ends. It's just the arrows. Today, we're going to talk about what's going on in the middle. So, if you guys could please turn to page 18 in your packet. We are going to start in your packet. So, this is page 18. And what I want to talk about is what's happening between the arrows. So the things that we're going to talk about is increasing, decreasing, and constant. It's always the same process. You always read a graph from left to right. So guys, let's pretend that I'm walking on an x-axis. And as I'm walking to the right, what's happening to the x-coordinates? Are they getting larger or smaller? They're getting larger. So when we talk about how a graph is increasing, decreasing, or staying constant, the x values are always increasing. We're always going to have a positive change on the x for every single one of these. And the reason why that is happening is because we are reading a graph like a sentence from left to right. So for this first piece right here, let me organize my work here. For this first piece, if I'm walking from left to right, I would be walking up the graph. My y values are getting bigger. But remember, we're in a function-based class, so we have to use the value of the function is getting bigger. As the positive change in x's, the values for the f of x are getting bigger. On the flip side, if I'm walking on this from left to right, I'm walking down. So the positive change in x results in a negative change for the value of the function. And then, again, guys, if we read this from left to right, y'all, the x values are increasing here. The x values are increasing. But there is no change in the value of the function. No change in the value of the function. Where it says things to know, here's a couple of things that you need to remember. Bless you. So remember, when we talked about end behavior, that was the arrows. When we're talking about whether it's increasing, decreasing, or constant, it's just the domain. Just domain values. You are only going to be able to tell me where a graph is increasing or decreasing by the x values. We're going to use the y values to figure it out, but the answer is only x values. And it is always parentheses.
No brackets.
Never, ever. Okay, so now, guys, take a look at these graphs. Take a look at this graphs. If you notice, all of the critical points that I talked about are on lattice points. Do y'all know what lattice is? Do y'all have vines at your house growing up some weird looking? That's lattice. And lattice points on a grid are just whole numbers. No decimals. They can be negative, but no decimals. If you notice, all of these critical points fall right on the black lines that are printed on your paper. Turn the page and go to page 20. Look at page 20. So if you notice on page 20, number 2. Number 2 has 2 critical points. It has a critical point floating in the white space over here on the left. That's going to make us do some work. And then your other critical point is right on the y-axis. Back to the one that's on the left side of the axis, the origin. That is going to take some work. I'm going to do some of these homework problems with you, but please make sure and please understand they're not nice and clean like this all the time. These are just our notes. So let's talk about how a graph is increasing and decreasing with nice ordered pairs that are whole numbers. Here's how this works, guys. When we read this graph from left to right, the first thing we see is an arrow. That arrow is pointing to negative infinity for x. If I tried to walk on this, would I walk uphill or downhill? Downhill is right. Go to your decreasing line, your decreasing blank, and start with negative infinity. I would walk all the way down to this point right here. And guys, what is this x value right here? -1, correct? So it's decreasing from negative infinity to -1. And then it pivots and it starts being constant. So as soon as I leave -1, I'm going to go to my constant blank. And it's going to be constant along the x-axis from -1 to positive infinity. You did not have any increasing behavior on number 1. Let's take a look at number 2. So for number 2, you have 2 critical points. Let me keep using the same colors that I was using. All right. You have 2 critical points. You have 1 critical point right here on the origin. And that critical point is a change in direction. It goes from increasing to decreasing. Then you have another critical point right here where it changes from decreasing, then it goes up forever. So on this, if you guys notice, we have 2 places where it's increasing. And just a little baby spot right here where it's decreasing. Which means I need to have 2 answers on my decrease line and only 1 answer on my increase line. So for the decrease, I start on negative infinity. No, I'm so sorry. That's so wrong. That's increasing. I'm walking uphill. It's increasing from negative infinity all the way to the origin. Once it reaches the origin, it hooks down. So I'm going to recopy this last piece as the beginning piece for the decrease. And then as soon as it hits that other critical point at +3, it turns around and goes back up. So write your union symbol. And now it's from +3 to infinity. Again, you did not have any constant piece on number 2. Say again. What's decreasing? Just this part I highlighted in pink from 0 to 3. All right, let's talk about the next one. For the next one, guys, you have 1, 2, 3. 3 critical points. And these critical points are a change in behavior. So the first piece, we are increasing. So on my increasing line, I'm going to start from negative infinity, and it increases all the way up to that x value. Is that a negative 4? Young eyeballs, 1, 2, 3, 4. Yeah, negative 4. What happens at the negative 4, though? Constant. Recopy that negative 4 at the constant line, and it is constant until x equals, is that a positive 2? Okay, let's finish up the constant with a positive 2, and then it falls. It goes down. Recopy that positive 2 on the decrease, and that graph falls for like 2 places. Y'all, is that a positive 4 right here? No. 3. I feel like that's a 4.
It's 4. It is 4.
Okay. I'm pretty sure it's a 4. It's so hard to tell. This graph is tiny. Then what happens after it leaves the positive 4? Go to your increase blank and write your U symbol and pick up positive 4 to infinity.